Okay, here we are on page 3 of 3.2 and just on page 197, just talking to you about solving applied problems using proportions, which is a fancy way of saying story problems, word problems. And just a reminder how you can use proportions for that. We'll demonstrate that right now. We can actually rely on our percent formula skills where we were practicing putting together the proportions. So let's move the camera here and we'll try one of these together. Alright, so number 36, let's read it, take a deep breath, read it again. According to the number of bass in a lake, wildlife biologists tagged 50 bass, released them in the lake. To estimate the number. They tagged 50, released them back into the lake. Later, they netted 108 bass and found that 27 of them were tagged. Approximately how many bass are in the lake? This is no longer your two cars leave at the same time driving in opposite directions. How long does it take till they're so many miles apart? This is a real life example of math at work, of how they estimate large numbers of things, especially out in wildlife when they can't get things to hold still or take a survey or do a census or anything like that. So they do this process of tag and release and then re-catch and count how many tags are. So they're using a proportion. So we can use our percent formula skills where we set up part over total equals percent over 100. So we can utilize our percent formula skill. Remember what we did there was we said part over total is equal to percent over 100. What we would do now is to use it in this manner, like this, where we would say we have part over whole is the same ratio as another part over the whole, okay? Where as you go across, both these parts here represent matching pieces. And as you go across the bottom, the wholes represent matching pieces. And as you go down, each ratio represents a matching piece. Now, what does that mean? Well, let's talk that through. Okay, so if we know we're setting up a ratio, a proportion, one fraction equal to one fraction, and let's look at what we're doing here. We want to know the whole lake. That's what we're trying to do, is to estimate the number of bass in the lake. So we're looking at a ratio in terms of the lake. What we have is a ratio in terms of the netted. Okay, so there's lake and netted, the whole group and then part of the group. Okay, so that's what we're looking at here. So we'll set up lake and netted. You can set this up lots of different ways. Then what we also have is tagged, and then we have all the bass, all the fish that we're looking at. Okay, so those are the four things. I've got lake and netted, tagged, and all bass. So let's look at what we know. How many were tagged in the lake? They tagged 50 and released them into the lake. Okay, so there were 50 in there. How many were tagged that were netted? 27 of the netted ones were tagged. Okay, now let's look at this. How many of the bass are in the lake? That's what we're trying to figure out. That's our goal here, is our X. How many bass are in the lake? So what's left? How many all bass were netted? So they netted 108. So that's the whole. So that's one way to do it. Once you've set up your proportion, then you can cross multiply. So we've set up 50 over x equals 27 over 108. It's kind of like two problems in one here. You have to do the translating to set up your proportion. Once you do that, you cross multiply and move on from there. So 108 times 50, that's going to give you, well, I guess we'll just write it like this for now, equals x times 27. Again, don't be alarmed that x is on the bottom of the fraction. Just follow through, trust the process, and that process is that when you have one fraction equals to one fraction, you cross multiply. Okay, so trust that process. 108 times 50 is going to give you 5,400. equals 27 times x. Then we divide both sides by 27 because that's all that's happening to x. And we should get x is equal to 200. And again, this is an estimate. That's the only thing you can get when you're tagging. Okay, so we estimate that there's 200 bass in the lake. Okay. All right, let's move. Well, we'll call that one good, and then we'll move to the bottom of the page for the last example. See you there.